Hi, grade sevens. Today we're going to look at how one of the methods for solving equations. This first method we're going to look at is solving equations by trial or systematic trial. And the reason they use the word systematic is because it's not just trial and error, there is a process to it. Now, normally when you see an equation like this one here, you know that you cannot, or sorry, an expression like this one here, you know that you cannot solve it because it is an expression. There is no equal sign. But you know that if somebody tells you that x equals 3, for example, then this expression now changes and it now means 3 times 3 plus 2. And we can solve that. 3 times 3 is 9 plus 2 is 11. So let's start off with a realistic situation here. Michael makes $14 per hour at his job. Yesterday he made $112. How many hours did he work? For now, let's just focus on this aspect, Michael making $14 per hour at his job. Hopefully you guys could tell me a good expression for this. Okay, because you know that he makes $14. That never changes. The part that changes in this case would be the number of hours that he works. So we would write that out as $14 H, or $14 times H. Okay, that would be the expression. All right. And what you guys would rely on me doing in the past would be to tell you what H was. And I would say, okay, H equals 4. And now you can tell me how much money he made yesterday at his job. But this question does things a little differently. So instead of it telling you what H is, this question actually tells you what the answer is. Okay. It tells you beforehand that he made $112. So the question that we have to ask ourselves is it possible for me to figure out what this H stands for? Because that's the question I want to know. I know how much money he made in the day. I know how much money he makes per hour. What I don't know is how many hours he worked. And so is there a way that we can use what we have here to help us figure this out? And there is. So the way that we do this is we use what we have and we make what's called an educated guess. Okay, we choose a reasonable number, a reasonable estimate number for the number of hours that he would have to work. It doesn't have to be a correct answer right away. In fact, it's probably not often going to be, but it has to be an answer that sort of makes sense. I'm going to guess for my first one that H equals 10. And if H equals 10, let's see what happens. If H equals 10, and my question is $14 times 10. I have to see what that equals, and that equals $140. Now, this is an incorrect guess, but it gives me a lot of information. What it tells me is that 10 is too high. And the reason I know 10 is too high is because my answer is too high. I want to get 112. I got a number significantly higher than 112. Okay, so I need to choose a lower number than 10 to help me. So what would be a good number lower than 10? Let's take a look and see if we can find something else that makes sense. Okay, so I'm not going to go 9 because I feel like I'm still significantly higher. I'm going to guess H equals 8. And that would mean now that my question would say $14 times 8 equals, and wouldn't you know it, it equals $112. So H does, in fact, equal 8. And what does that tell me again? What's the real life use of that? What did H stand for? H stood for hours. So this tells me that Michael worked for 8 hours. Okay. See what I did there? I used a number that would be a friendly number. I love to use things like tens and fives because they're so easy to multiply by and they give me a really quick estimate, even if I know it's going to be wrong. I knew 10 wasn't right, but I didn't know if it was 8 or 7 or 9. So using 10 gives me a really quick guess. It will help me also know right away. I know it's not going to be higher than 10, so it's not going to be 11 or 12. It lets me know I have to guess downwards, and it lets me know, gives me a ballpark in which to try. Almost always you can get it within a couple guesses. So now we're going to try a few different ones. So I'm just going to go through these. If you want, you can pause before I do each one and test it for yourself. I'm going to solve them, and then if you can check, you can just turn it back on and check your answers. So let's try this one. 7n equals 84. I'm going to guess that n equals 10 again, and that's going to mean that my answer is 7 times 10 equals 70. So my guess is too low. So I need a new guess for n. And I know that 70 is 14 less than 84, and 14 is 2 times 7. So I'm going to guess that n equals 12. It's 2 sets of 7 higher, and that would mean that 7 times 12 would indeed give me 84. And so now I know in my answer, and I would write it down over here, simply n equals 12. I have to make sure that I include this at the end or I haven't answered the question. If I just stop here, I haven't really solved it. I want to make a definitive statement at the end that yes, n equals 12. All right, let's try one with some subtraction here. I'm going to start off by saying, so k equals, I'm going to go 90. K equals 90. That means that 90, I substitute that in there, minus 9 equals, it does not equal 79, it equals 81. I'm close, but not quite. So now I know I need to go a little lower than 90, right? Because I went 90 and I was too high. So I just need to go 2 lower, 88 minus, so I'm going to sort of say K equals 88. And I'll plug that in and try. 88 minus 9 does indeed equal 79. So I have my answer. K equals 88. Okay, this one has some addition. Let's try here. Okay, P plus 14 equals 40. I'm going to say that P is, let's say 25. P equals 25. I'm going to plug that in, 25 plus 14, and that actually equals 39. So man, I was really close, but not quite. My answer is too low. So that tells me that my next guess, P should equal 26. And let's plug that in to be sure. I always want to test. Plus 14 does equal 40. So I do know that P equals 26. Okay, just a little bit different one here. This says T-5, sort of slash 5 equals 22. I hope by now we've all got in our heads that that slash is another way that you can type a division sign, right? So this is saying basically T divided by 5 equals 22. So let's see what we can do here. T divided by 5 equals 22. I'm going to start with 100 because I know that 100 divided by 5 it gets me into the 20s. So 100, so I'm going to say T equals 100. Plug that in, 100 divided by 5, and that actually equals 20. Okay, so that tells me that my answer is a bit too small. 100 is a bit too small, but it's only 2 off, right? So that means 2 sets of 5, right? Because I'm dividing by 5. So I'm going to reset this to T equals 110. Try that. That's 2 sets of 5 more than my previous answer. So I'm going to plug that in, 110 divided by 5. That does, in fact, equal 22. Okay, so I do have my answer. T equals 110. Okay, this one's a little trickier because it's got a couple parts to the initial expression. 4w plus 4 equals 52. So don't really have to worry too much about that plus 4. I just have to sort of keep it in mind. 4w plus 4 gives me 52. I'm going to use w equals 11 because I know that 4 times 11 gives me 44 plus 4. That's getting me pretty close. So that's going to be 4 bracket 11, 4 times 11. You guys know both those by now. Plus 4 equals, now I hope we are doing bed math. 4 times 11, we obviously do that first. That's 44 plus 4 equals 48. Okay, so I was close, not quite. So I'm going to go one higher, and I'm going to do W equals 12 and try that. So 4 times 12 plus 4 equals 4 times 12 is 48. Okay, plus 4 is 52. So I do have an answer now. Okay, W equals 12. And this one is probably one of the trickiest kinds to do because it's a subtraction. So 3z minus 16 equals 74. That means that this 74 is about 16 smaller than whatever this 3z is, right? So mentally, it's kind of helpful if I can sort of figure out that 3z has got to be bigger than 74. I'm not aiming to get to 74. I'm aiming to get something a fair bit bigger than 74. 3z, I'm going to go z equals 30. The reason I'm going to do that is because 3 times 30 is 90, and then I'm going to minus 16. So let's see what happens. So that equals 30. So now I'm going to do 3. I'm going to use brackets to try and keep you guys remembering to do that. 3 bracket 30, which is 3 times 30, minus 16. And 3 times 30 is 90. Minus 16 does, in fact, equal 74. So sometimes you just get it on the first try. 30 was a real convenient number for me to try, a real friendly number, but in the end, it ended up being the right number as well. Okay, so 30, so Z equals 30. Okay, so test those out, try some of your own, and we'll see.